Hi, today I'll be talking about Physics Lab 4 Oscillations. So here's my introduction. The purpose of this lab was to predict the motion of a spring mass system using the energy principle and coding. Some of the models and principles I used in this lab were the energy principle, Newton's second law, tracker, and glow script. And a preview of my results is that the system demonstrated the energy principle because the total change of energy remained at 0 the entire time. So here's the experiment. I analyzed a video of it's a weight attached to a spring and it oscillated vertically and horizontally, and I analyzed the motion in tracker here. So for every time step, I clicked the center of mass and it gave me its position data. The system is the weight, spring, and the earth. The surroundings are none. You should note that because there's nothing in the surroundings, delta E of the system should be 0. And this blue line here is a 0.7 meter calibration stick that I put in tracker to ensure that it gets correct position data. So here are the fundamental principles at play during this lab. So we have the force of gravity, we have kinetic energy, we have gravitational potential energy on Earth, we have spring potential energy, we have the energy principle, which is delta E equals delta K plus delta U. We have the energy principle of energy equals work done by the surroundings, but in this case we set the surroundings to nothing, so delta E should be 0. We have spring force, we have the position and velocity update functions. And the velocity update function or velocity update equation uses Newton's second law. So here are the initial conditions for my glow script coding. The ball of the mass, the spring constant, and the relaxed length of the spring were given by an introductory video on this lab. The position was, I got the position through using tracker and setting the origin, and I assumed that the ball's initial velocity was 0 because I began tracking it while it was at rest. Now that the initial conditions have been entered, here's the primary part of the coding. So this is a while loop, which is going to update the system's kinetic potential and total energy for each time step. And here's some of the fundamental principles used here on the left. There's the force of gravity, spring force, and notice that in line 120, F net is only the spring force plus the force of gravity because there are no other forces acting on this system. In line 124 and 126, we have the velocity and position update formulas. And at the bottom of this code, delta K, delta UG, delta US, and the system's total energy are all updated before the while loop begins again. So here are my results. The first two graphs on the right are my predicted position versus time given by the model and the actual position versus time. As you can see, there's clearly some error here. A potential source of this error could be that I set the initial velocity as 0, and at that exact frame, maybe the mass had already begun moving. There also could have been some human error in me choosing the center of mass. As you can see down here on the bottom, with the center of mass, I clicked a spot that's slightly off center, and the model also does not account for drag or air resistance. So for this discussion, is the energy principle satisfied? It is. As you can see on the change in energy versus time graph, as delta K increased or decreased, delta U gravity also changed proportionally so that delta K plus delta U is always equal to 0, and the total energy of the system, the total change in energy of the system was always 0 as well. And this also works because we set the surroundings to be nothing, so the surroundings never could do any work on the system. So on the left, for the X position data, the oscillation period was 1.5 0.19 seconds, and on the right for the Y data, it was 1.425 seconds. Why are these different? It could be due to error in tracker because I could have incorrectly determined the center of mass a few times. It also could be a lack of drag force being accounted for in this model.